Welcome back to the channel, Bridging the Gap, Student to Engineer, where STEM professionals provide advice to students. This video is another discipline deep dive, this time into materials engineering. This is one of the more specialty engineering, and I've gotten a couple of requests for it, so let's just get right into it. All right, so material engineers, like all engineers, identify, formulate, and solve complex engineering problems by applying principles of engineering, science, and math. 2, research, design, and improve materials used to create a wide range of products and to enhance those products, lower production costs, and improve product features. Design materials for specific uses across many industries, from aerospace to biomedical to large structures. We need material engineers to improve the materials that we're sending into space or into the air, improve the materials that we're putting into people's bodies to help them get well as improving things like concrete and steel for large structures. So it's a wide application. Like a lot of engineering, you'll see materials engineers in a number of industries. Material engineers also perform tests and analyze failures to ensure that materials meet technical and cost specifications. So if there's a new design out there, and they're constantly at the leading edge of material science and engineering, you're going to be doing a lot of tests and analyzing why it failed, and then coming up with designs that improve that material for whatever the application is. I will pause here and say that a lot of the programs that are at schools are called material science and engineering. And the reason for that is that while science is discovering new materials, discovering new compounds, new minerals, those types of things, engineering is the application of those materials to products that we use every day. And so, depending on the role of the material engineer or the material scientist, there's a lot of overlap there, where you're discovering new things and then figuring out how to apply them. Um, just like in a lot of cases, if you're discovering something new, it's not as interesting or as useful if there's no direct application to some need or some gap that's out there. So there's definitely a strong overlap, and in some cases, you'll find people doing the science and the engineering together. Okay, so career outlook. 2024 is the latest data that's available. The median pay for everyone across the US with the materials engineer title is about $108,000. That is a very healthy number. That is on par with most other engineering disciplines. And like other engineering disciplines, the typical entry-level education is a bachelor's degree. It's one reason why engineering is interesting and attractive to a lot of people, is that you can get out into the workforce and work making a pretty healthy income just on a bachelor's degree. As far as the number of jobs in 2024 in the US, $20,000, 20,000 jobs. This is compared to some of the larger, more core engineering, where we're seeing about 300,000 jobs across the US. So this is, on the order of 8% to 10% of what those more general, broad, larger application, more needed disciplines are. But that's not to say that materials engineering is not a really good option. The growth in the next 10 years is still projected to be 6%, which is healthy and faster than average. So definitely something that is interesting to get into and has a lot of options once you graduate. Okay, so industry organizations. If you watch any other of our other videos for discipline deep dives, you know that I feel like industry organizations are extremely important, even when you're a student and not yet out into the workforce. It is really good to connect with industry organizations, become a member. They are generally cheap to allow students into the organizations. Look at where they have webinars, meetings, locally or online, and across the US. All of these pretty much will have like some sort of large annual meeting that you can go to. What you will find going to meetings for organizations like this is that there is so much more out there than you're aware of, and it can really give you some good insight into the industry, but also a passion for something that you didn't know existed. They also often have scholarships, so that's a nice little monetary thing that you can definitely look into. But within materials, there are a couple general Society for Advancement of Material and Process Engineering, but then there's quite a number that are specific, like ceramics, plastics, mining and metallurgy, those types of things. And so if you are just starting out on your journey, or you're not yet in college and you're looking at material engineering, definitely look at some of these specialty ones, and just think about where we use ceramics or plastics in our everyday lives, and think about whether or not you would be interested in spending your career focusing on making those materials better. So the American Institute of Chemical Engineers is on here. Some of these more general societies for the larger discipline engineering have specialty organizations within them for things like material engineering. So that is the case with the American Institute of Chemical Engineers. So check that out. And just along those lines, if material engineering is not an available major, chemical engineering may be something that you can look into and see if the school that is local to you or is the least expensive to you has chemical engineering with some material focus, is another way of getting into the discipline. Okay, so let's look at schools. 60 to 70 ABET accredited, that is a range because it really depends on like what specifics you're looking for. But if you just look at materials, there's about 60, and then there's some other accredited programs with some similar titles. If you look at these schools, at least the ones that are listed here, they're for the most part large public universities. It is not very common to see materials engineering at small schools or at small private schools. And what the larger schools are allowed to do is that they have more options because they have more students there. And so it's just something that that you'll see mostly at large schools. That's not to say that there aren't some small schools, but definitely something that is more common in large schools. I will say that Colorado School of Mines is about 5,000 or 6,000 students, so that is smaller than a lot of these extremely large public schools like Michigan State or UC. But Colorado School of Mines is just technical, so just STEM focused, and so their entire school is typically the size of the engineering school in a lot of these other schools. Okay, so outcomes. So let's just start with a few caveats. One is that the schools listed here are not necessarily the ones we recommend for materials. They are the schools that give us the data that we can compare with other schools. A lot of schools only will give you the student outcomes for their entire engineering school rather than by major, so we can't include them in here. But having said that, this materials engineering deep dive will be the first video in a playlist for materials, and we will put in that playlist the schools that we've done reviews of that you might want to consider if you are interested in materials engineering. And the list is longer than what's on here, so that's good. Okay, so if we look at annual grads and percent of total engineering, all of these are small. The ones with the greater than sign just means that the number provided there, like 21 for UC Berkeley and 50 for Purdue, those are the numbers that replied to the survey, the first destination survey. But they don't give us the number of actual grads. But we can compare that to the total number of engineers who responded to the survey and get an estimate on the percent. So if you look at these, they range only as high as 5%. So definitely a small group. And even if you are in a large university, you're going to find yourself with a small group of people with your major. And so sometimes that can make a large university feel a lot smaller, at least when you get into your junior and senior year. So something to consider if you are worried about school size or particular about that as you're going along. Okay, so in the middle, we've got grads, positive outcomes. Like all of the other disciplines, or most of the other disciplines we've looked at, there's quite a range here. So we go from 72% to 98%, all, somewhat reasonable, although I really don't like to see any positive outcomes in the 70s at all. And the percents here are not necessarily lined up with the rest of the disciplines within these schools. University of Delaware, for example, in some other majors is in the 90s, and UC Berkeley in other majors is in the 70s. So not necessarily just an indication of the overall results from the university, and just kind of shows you that the different universities are different majors within different universities are different. And I would attribute that range to employers knowing certain schools as being really good in some programs. And so the employers who want to look for materials engineers, for example, might target Purdue or Berkeley more than they would Washington. Okay, and then if we go over to percent grads employed versus continuing their education, typically just overall engineering, we see about 20-25% of grads going on to continue their education. There is a lot more variation in these numbers than some of the other disciplines. And so just something to consider. Delaware and Virginia Tech are pretty low in grads continuing, at least for Virginia Tech. That's pretty standard for the school. 50% for Purdue is actually pretty high for the school. Most other disciplines have a lower number of grads continuing their education. The reason I just point this out is because if you are 100% going into your undergrad thinking the only thing you're going to do when you graduate is go get a job because you need to do that right away, going to a school with a lower percent of grads continuing their education just means you'll be surrounded by more people like you. None of these schools are you going to see zeros for grads continuing because there are always going to be people who graduate and then decide that they really need to continue their education. Okay, and then we look at median starting salary. These are pretty typical numbers across the US. We're seeing mostly 70s and some schools into the $80,000 for first salary getting out of school. Berkeley, being in a very high cost of living area, is higher than average for all disciplines, and the 95 is about typical, and maybe a little bit lower than some of their other disciplines that are more computer and tech related, given where they are in the Bay Area. Okay, so first employers. These are all employers that were listed by actual schools. Not very many schools list their employers, and so it takes a little bit of digging. But what we see here is a pretty interesting variety of industries, and not necessarily the same industries as we've seen in other ones. So when we looked at like mechanical and electrical, there's a lot of automotive. I didn't see any automotive in the schools that I looked at that provided first employers. But what you see on here is aerospace, defense. Pratt and Whitney does a lot of engines and those types of things. Things that are on the cutting edge of, or need to be on the cutting edge. Defense is and space are definitely in that category. They really depend on the latest and greatest materials to be able to be successful. So very important in those industries. And that's where you're going to have these really large companies that are going to hire a group of material engineers who are going to be focusing on improving the way they use materials or improving the materials themselves. One thing that's interesting on here is Danone, North America, they make yogurt. So that's an interesting one to me. And then if we keep going down, we see DuPont. So DuPont is chemicals. And then we see aluminum and timber. If you're a company that is providing wholesale materials, you definitely want your materials engineers to be there developing the latest and greatest so you can be on the top of the industry. Okay, so as first job titles, material engineer makes sense. Now, quality engineer is someone who's going to be making sure that the manufacturing process is accurate and testing those materials like we talked about in the beginning. Laboratory technologist and metallurgist, these are more on the science side and less on the engineering side, but definitely things that you can do with a material science and engineering degree. You'll see a lot of material engineers focusing on metal, steel, and those kind of things, and that's why the metallurgist is there. And then module engineer, test engineer, you'll see those a lot in space and defense and shipbuilding and those types of things where you're going to be focusing on a module within a larger aerospace type item that you're working on with your team. Okay, then resources. So I've been mentioning lately this engineering expectations. I will provide the link to this in the description of this video, but they have a website and they have a workbook. This is a very small company focusing on helping high school students look at various options within engineering. And so it's a really good resource if you are looking at options. Aside from listening to these videos, you can go order that workbook and work through it with your student. And then the Wikipedia Material Science page is it's a pretty interesting article with the history of material science. It also talks about materials engineering and talks about the difference between those two. So it's a pretty comprehensive article if you want to just start there as a way of getting information. And then the University of Maryland Department of Material Science and Engineering on their website has a page called Our Favorite MSE Links. And there are a lot of different links there that I highly recommend going through. Some of them are games. Some of them are just interesting articles about materials and how they work. And definitely something that can be more entertaining way of getting into material science and engineering than just reading an article or something. There's a lot of resources within there. Right, so that is everything we have for material science and engineering. Please like the video, subscribe, share with a friend. Listen through the playlist for this major. We'll add a bunch of schools that we've reviewed that we recommend you look at if you're interested in material science and engineering. If you have any questions, feel free to leave them in the comments and we will get back to you. Other than that, we'll see you on the next one.